Hi everyone. Please come back those who are still eating. I'm about to start, so thanks Marcus for the introduction. My name is Mindaugas and I'm from Attention Insight. I'm going to talk today to you about building a reproducible machine learning pipeline. First of all, I would like to just quickly define what I mean by reproducible. In this particular case, I'm going to talk from the aspect how can you build such a pipeline that it is easy to both reproduce the results of how you run your machine learning workflow, and also how easy it is to replicate the earlier runs that perhaps yourself have done previously or someone else has done, and as well as how can you build such a machine learning pipeline that allows you to easily or make it easier to port your pipeline from one environment to another. So to start with, to build the machine learning pipeline actually drove the idea of rule number 4 of Google's machine learning rules, which states that we need to keep the first model very simple and get the infrastructure right, which means that we don't necessarily need to have the best performing model when we are building a product, but first we need to lay a solid foundation for the solution that we are creating. So to do this, we need to employ a certain process that is well defined and allows you to save a lot of time going forward when you do a lot of iterations between going from getting your data to actually deploying your solution to production. We at Attention Insight work with eye tracking data, and we believe that we can know where users might look at the content. It is said that between 4,000 and 10,000 ads is displayed every day to an average American. So this begs the question, obviously, how do you know to which ads is the user going to interact with? And the main question here that we want to answer is it possible to predict where people will look? For the next 5 seconds, I'm going to show you a picture, and you can have a look and just think when you are looking at it. Okay, so experiment over. This is what our algorithm thinks. It doesn't understand the semantics, but it can guess where the attention is going to be distributed. And how about if you have a more difficult content? So imagine a web page with a lot of, say, words, a lot of various icons. How do you train such a model effectively that allows you to enhance the performance of your model? So that is the problem that we came across, and hence why I'm talking about pipeline and why I'm showing you what we're doing. What we needed to do a lot was do a lot of iterations to retrain the model many times with different parameters, with different sets of data to get an accurate prediction. Now, to enhance this particular situation here, we can retrain the model as well, but we might need to reuse some earlier data sets or reproduce some earlier results. And we were just looking at what might be the best method of doing this. We wanted to first lay a solid foundation to save time between our iterations. When looking at this picture, you might remember this from the earlier Meetup, where our colleague from Adform has shown. I've blown it up a bit just to underline how far apart some machine learning pipeline steps can be from one another in terms of what knowledge they might require and when do they start and when do they actually end. It doesn't require, machine learning code doesn't require the most work. Usually the most work might be required to actually do the proper serving infrastructure once you scale, or how do you handle the machine learning resources, or how do you do the data collection. And there are a couple of tools that we looked at that can be employed to more effectively manage the way of building the workflow. The first is TFX, TensorFlow X in other words, that can handle the data part. Next, to handle the resources, the infrastructure side of the pipeline, we can use Kubernetes, which handles the containers that your solution is deployed to. And another tool that can be used to act as a glue for all of this is called QFlow. It is an open source project created by Google, which actually can join the various parts of your machine learning code, or in other words, you can define a machine learning pipeline to save more time when starting from data ingestion to actually serving the model. Usually, when developing a machine learning solution, you are obviously taking care of this full stack on the left. You take care of the hardware, the OS part. You are training the model. You are serving with this via the UI. You take care of the frameworks. But what happens when you need to deploy this to production? Well, first, need to move this to, say, a test environment, and deploy this to production. You can use Kubernetes and QFlow to easier manage this because it allows you to abstract these activities more. So QFlow can take care of the model UI, tooling, frameworks parts, whereas Kubernetes can handle the resourcing part. To start with, we looked at deploying Kubernetes and QFlow first to have as a quick win to building our machine learning pipeline, because to build everything on TFX just would have been too much time consuming for us to rebuild our code base. So what we looked at first is deploying QFlow and Kubernetes. And actually, to get started with Kubernetes and QFlow is very simple. Just simply via the UI. If you use Google Cloud Platform, this tool can be used. You only need to have you only need to provide a project name, and you need to provide certain permissions for it to get installed. This will create a QFlow cluster for you, and will deploy the QFlow Kubernetes cluster, and will deploy a QFlow instance on it. Just to mention that QFlow can run any machine learning framework code located within within a container, and Kubernetes will handle the resourcing part, providing the necessary resources to the container that requires. Now, I have mentioned what containers, but I didn't explain what they are about. Really, the containers, if you've heard about Docker, images, can be thought of as parts, can be thought of as self-sustaining mini machines, or that contain in themselves everything needed to run a specific code that is in those machines, which means that QFlow can take one container and sequence it by joining it to using to the other, that way creating a workflow of events. To deploy QFlow, you can do it on Amazon, on GCP, on Azure, as long as the provider can run Kubernetes. You can do on premises as well. And I'm going to talk more specifically now about what your project, as an example, what an example project looks like. So imagine you have a machine learning solution which has three imaginary parts: ingestion, train, evaluate, and deploy. These can be thought of as separate modules. They only need to have in their own Docker file, and Docker file allows you to build a specific image just for that part. So you would end up with an ingestion image, train, evaluate, and deploy image. What you can do next, you can build a pipeline in QFlow to schedule, actually to make a workflow saying what happens after what. So if, say, I have a data set and I want to use the ingestion engine to get the data from that data set, I will set as an argument in my ingestion engine the input of the data set. The ingestion engine, since it has that code that handles the data, will handle it, and it will pass the relevant output from the ingestion engine to the train evaluate step. Be it, for example, where the new data has been saved, and then train evaluate will pick up that output of the previous step and do its thing. So it will train the model. This is, again, a very simple example. It will train the model, and possibly it can output the model for somewhere in for example, Google Cloud Storage. And that way, the next step, deploy, will have an input such that it says, pick up the model from that location. And it allows you to visually see where what your inputs and outputs can be and what it depends on what. QFlow also supports Jupyter Hub, actually has Jupyter Hub, and to define QFlow pipelines, you can use Jupyter notebooks. So when you spin up a Jupyter Hub instance, you can create a new Jupyter notebook, and by using a specific domain-specific language to create the pipeline, the syntax of which is really defining functions and then sequencing when the functions run, you can create QFlow pipelines within QFlow itself, which means that once the QFlow instance is deployed on Kubernetes, you can work on that QFlow installation. So you create the pipelines, you upload them into QFlow UI, and you run the pipelines. So I've talked about how we create pipelines, but I haven't said how you actually run them. So you run these pipelines in what is called experiments and runs. So the experiment can be thought of as I have a pipeline. For example, I have a version 2 pipeline, and I want to have an experiment that works only for, say, dataset 1. So dataset 1 is just a certain subset that I want to run multiple experiments or runs against. Specifically, when you perform a run of a pipeline, you can set what are your parameters going to be of that pipeline, which means that you can reuse quickly the same pipeline to run with different hyperparameters. And that also means that not only you can do it, but others can as well, which means that you can share the same running of the pipeline in a quite simple collaborative way. After you've done the runs, you can check out what the results were. You can output what results you want to show, and you can check what the hyperparameters were being used to train this model. What it allows you to do is allows you to check out the historical runs, to come back and say, okay, I see that I have this a worst performing run, and I want to check out what it is. So this is a dataset run only for LR1. So this is it's the first column. And I can see what hyperparameters I had then. And I can see also the last 2 rows, what versions of the images from my code I had. So knowing all that information, you can later, if you know that a certain sequence of certain code steps has performed best, you can rebuild the pipeline with the same versions of images, with the same hyperparameters to reproduce the actual results. So be it yourself or somebody else who, for example, wants to see how well your run has performed. You don't need to share, say, VM images or logs or any type of not a very convenient way of collaborating with your colleagues, for example, if you want to share the early experience. You can check out what the logs are for each run. So if you're in a training step, you might want to have a look how well has it performed. And you can see that the logs and the runs, the screenshot excerpt here of the screenshot is of the run that I showed earlier, is that you can go back, say a week ago, what the runs were a week ago, and you can check out what the logs were. So you wouldn't need then to save your logs of your earlier outputs earlier somewhere in a shared drive or in a local system. It's very easy for both yourself or for others to check out what was happening during that run. It's very also convenient when you need to reproduce the error, because you will be running the pipeline in the same sequence with the same Docker images when the error occurred. So you don't lose the ability to reproduce the errors, which is often very important to do. I haven't mentioned the tensor board is integrated in QFlow as well. So if TensorFlow outputs to a TensorBoard output, you can check out in the TensorBoard what was happening as well. So if you want to reuse previous steps of a certain previous versions of a certain step, for example, if I know that on the train step, when looking at the run parameters, I know that say a version 3 performed using it, my model performed best. I can just simply choose which Docker image I might want to reuse later, because maybe the training code performed best on that particular version. And just to conclude, really the ideal pipeline, obviously the simple one, for more complex problems, it won't be that simple. It would be enough in the beginning to set what the images were. You set the certain hyperparameters, what project this is for, and that would feed to the pipeline, to each step, to know what the pipeline needs to perform. Specifically for our situation, for example, you can see in the middle the fixation start and fixation end are the parameters that we use to get eye tracking information. So when we said that we predict attention in certain parts of the image, we can also predict during which time span that attention is going to be predicted. So from 0 to 4 seconds, or maybe from 0 to 3 seconds. So when we retrain our model, we can train such a model that is for a certain time span, for example. Yeah, and then you can check out what the QFlow is about on GitHub. You can use the easy-to-use UI to install it. If you are not on GCP, you just can register for a free account. And then there's a useful projects pipeline guide that you can read more about. Yeah, so thank you for your attention, and happy Valentine's.
Thank you, Mindaugas. Anyone with questions?
Thanks for a very informative talk. Do you know if QFlow can be used for different kind of pipelines, not using machine learning?
Yeah, sure. Yeah. So as long as what you want to do can be packaged up in a Docker container, you can do that, because really QFlow is kind of orchestrator for containers. As you might have seen in one of the last slides, it's enough for you to say what image of the container are you using. There's nothing machine learning specific in the settings of the pipeline. So in QFlow, you can even avoid using on certain steps, which is not advised, but you can. In QFlow, you can use Python functions to actually run as a certain step. You don't even need to package something in an image.
I don't think we have any other questions. Thank you again, Mindaugas.
Yeah.